10 point, what, this is 10.3. So again, MTS ALG2. Homework 10.3 questions. So we just did the unit circle. So if you need a unit circle, look back on 10.3 unit circle. But this is the questions 19 through, what am I going to get through? Does that take 29? 19 through 29. I can't talk for some reason. All right. Grab some colors. Okay. Let's do this. They want you to translate this, and they're going to expect you to do it without a calculator. It's not that hard. Okay. Again, we have to know how.
Is it just 8 pi over 6? That's what
This is pi over 180, right? Pi over 180. But when I'm changing radians to pi or radians to degrees, it's going to be 180 over pi. And 180 over pi. I mean, that's the hardest thing to remember. Okay? So degrees, pi over 180. Radians, 180 over pi. And it's pretty easy to remember because almost always will they give you a radian in a pi over something. Once in a while, somebody's going to give you a degree with pi in it. And all they're doing is messing with you because we never put pi in degrees. I mean, this doesn't happen. But they do it on some tests. I've had it on tests for when I was in trig. But I never seen it on an SAT or anything, so I'm not going to do it to you. Okay? Just know that if it says degrees to radians, you always do this. Okay? Now, I like to just do the upside down division. Right? And so I know that 10 goes into here. 24 pi over 18. Right? And then I do it again. What goes into 24 and 18? 2. Or, yeah, okay, 2. And that's going to be, what, 12 pi over 9? And then, because I'm running out of space, I guess I could have gone down instead of whatever, but whatever. That probably would have been the best thing. Oh well, I'm not the best guy in the world. So 12 pi over 9, and then what are we going to do? What goes into 12 pi? 12 and 9? 3. So, again, 3, and I get 4 pi over 3, or 2, or 3. Okay. Now, we should have known that, right? Because if we look at our unit circle, what's 240?
8 pi over 6 and 4 pi over 6.
Boom. Okay? So we could have looked at our unit circle for this one. Okay?
So is that the answer?
Yeah.
4 pi over 3.
4 pi over 3. Okay? So we could have looked at our unit circle, but we can't look at our unit circle for this guy. Right? 25 isn't a normal 30, 60, 90, or 45, 45, right? Even though negative 25, if we think about negative 25, right? It still isn't going to hit that negative, the 315 degree that we were looking for, right? But anyway, talking about negative 25, we know it's going to be negative, right? So if we pull out looks like a 5, right? That's going to be negative 5 pi over what? 5 goes into 18 3 times. With 3 left over, and 5 goes into 36 times. And I don't think I can break down that, right? So we're done, son. Right? Same thing with this guy. The first thing I want to pull out is a pi, right? What that's going to give me is a negative 180 over 9. Okay? Now I can look at that and go, well, 9 goes into 9, right? And 9 goes into 18 So negative 2 times, so there we are, negative 20 degrees. Okay? Alright? Same thing here. I like to take out the pi. Right, so now I have 7 times 180 over 2. I don't put those together. I just rather take it apart piece by piece, right? So what goes into the top and the bottom? A 2 does, right? A 2 goes into, it doesn't go into the 7, right? But it does go into the 180, 90 times, right? So I got 7 90s, which is how much? 630, right?
630.
Sorry, I was like tripping. I thought maybe I did it wrong backwards in my head. But yeah, so we just got 630, right? And there it is. Okay, transferring pi's radians to degrees, degrees to radians, right? Sometimes we get to use the unit circle. Sometimes we don't, but we never use the calculator there. So they're going to probably do that to you on the SBAC. Okay? Now, in the same aspect, they're probably going to come at you with this. So we have to know our SOHCAHTOA. We have to know the other 3 functions. Alright? So on your SBAC, as soon as I sit down, I would draw the unit circle. Right? I would draw the unit circle and fill in those numbers. Okay? And then I would put in sine, cosine. So SOHCAHTOA. And then from SOHCAHTOA, I would put in cosecant, secant, cotangent. And they're inverses, right? So no co. I would go, so sine is, and that's a no co, so the co over here is cosecant. Cosine has a no co attached to it. So secant has, notice how there's no co on secant? You see what I'm saying? It's secant. There's not a co there. Cosine has a co. So every single one has a co and a no co. Alright? And so tangent's easy. Tangent and cotangent. They kind of go together like white on rice. Okay? But with the sine and cosine, I always got confused when I was your age. And no one made it make sense to me. And then I noticed that they're always a co or no co. So one has a co, like cosecant, and one has no co in front of it, like sine. Those go together. Those are inverses. Once I can remember that, right, it's huge. Because now I have something I can use on the test. And I know if this is opposite over hypotenuse, then this is hypotenuse over opposite. This is key to doing SOHCAHTOA on that state test. Especially on the geometry at the end of the year, which I'm going to have you do. And I'm also going to have you do the algebra. Just because if you're having a hard time doing the ACT, we've got to have you do everything else then. If you're not going to do that one, right? Okay? So, it's huge. And the reason why this is so huge is because when I look at this tangent 300, I need to know, okay, when I look back there at my unit circle, where is 300? And I see that 300 is this guy right here, right?
Do you want to work that out?
And, well, yeah, we're going to have to work it out. But the cool part is, oh, write that out. I mean, I would, but you don't have to make the whole unit circle. You can just make this one piece of the unit circle. So it's 300, right? You don't need, in this case, to know the pi. You don't need to know radians, right? Because this is 300. This is where 300 is. What you do need to know is what this is talking about, right? Okay? So, the cosine, the tangent of 300 degrees, right? Or this whole angle, okay, is going like this, has to do with this reference angle, because that's your reference, right? So, I mean, it would be easy for us to plug this in, right, and go tangent 300. And if they let you, do it, right? Because it's coming up as a negative, okay? And the one thing I would look at here is when this angle is down like this, then this looks like it's a negative angle, right? And remember I said the reference angles are not negative? Well, we're going to talk about which ones, where tangent is negative, where tangent is positive, right? And in this case, it's negative, right? So in my head, I'm going, okay, this looks like a negative angle, like a negative 30 degrees, or I'm sorry, 60 degrees, right? So is that the same? Is tangent of negative 60? And it's the same. It's exactly the same. So it's looking at this as a reference angle. It's looking at it as a negative 60 degrees. So now I can look at it and go, okay, tangent of 300 degrees is equal to what? Tangent is equal to? Think about this. Tangent's equal to? Yeah, opposite over adjacent. So, okay, we did it on a calculator. We proved that it's going to be negative. But why is it freaking negative? I don't get it. Well, this is why. What is this from here to here? Right? And when we think about that 30, 60, 90, right? Remember the short leg was 1. The hypotenuse, right, is 2. And this piece is square root 3. Right? So now I can say, well, opposite is square root 3, right? This is opposite. This is what? Adjacent. So this would be adjacent. Okay? So what's going on here is it's 1, so this is equal to opposite is square root of 3. But wait a minute. This is going down, isn't it? Isn't this length going down in the xy quadrant, right? So therefore, this is negative square root 3. The length is negative square root 3. This point right here is negative square root 3. So if it's negative square root 3 over adjacent, which is adjacent has to be 1, right? So this is really equal to this negative square root of 3. Now, when you plug in the negative, it better come out to be negative 1.73, right? Because that's what tangent of 300 is. So if I plug in negative square root 3 and hit equals, I get, again, negative 1.73, blah, blah, blah. Because it's a radical, it goes on forever. So this is why it's coming up negative. It's because it's this part right here is negative. Now think about this. When this part's negative and this part's negative, what's going to happen over there? 2 negatives. Yeah, it's going to be positive. So you can't think of it as a reference angle being negative. You can't do that. Because this reference angle would be negative then, right? But it doesn't work out that way. That's why all reference angles are positive. We're thinking about them positively. But in a quadrant, we're going to think about what that thing's doing. When we're talking about tangent, we're talking about opposite over adjacent. In this case, the opposite side is going to be negative. In this case, it's going to be negative. But in this case, the adjacent side is also going to be negative, which makes that thing positive. That making sense?
Yeah.
Alright, so now we do cosine 5 pi over 6. So I look at 5 pi over 6 on my thing. If I don't have my chart, I think, oh, 5 pieces of pi over 6 pieces. There's 6 pieces, right, in here. So that I should know. I should know that that piece is right here. This is 5 pi over 6. Right? So this is a 30-degree triangle. Right? And I'm doing opposite, which is 1. Oh wait, cosine over hypotenuse, which is 2. Right? Now are these both negative?
What?
See, this square root of 2, or this 2 is actually negative. Why is that distance negative? Why is that a negative distance? Right? No, it can't be. Distance can't be negative, right? Distance is always positive. Alright, so it's just 1/2. Okay, so cosine is going to be adjacent, which is the square root of 3 over hypotenuse. So this is going to be equal to the square root of 3 negative square root of 3 over the distance of 2. Now if I found the distance, that would be what? The distance formula is the square root of, right? Blah, 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 all this stuff squared. That's always going to be positive. So distance is always going to be positive. No matter where it's at. Distance is positive. But, so this will be positive, but these are negative and these are, this would be positive in this direction, right? And that would be a positive 1. But we're doing cosine, so cosine would be adjacent over hypotenuse. So that would be negative square root of 3 over 2. Now if we think about this, this would be the same as cosine of 150 degrees. So when we do cosine of 150, we get negative 0.86, right? So that's good because we're coming up with a negative something. So when we do negative square root 3 equals, and then divided by 2, right? Perfect. Negative 0.86. So that's exactly what we wanted. This is exactly what we're looking for. So I just want to make sure because I don't want to say something and then be wrong. Right? Math is great that way. You can always prove yourself. Double check it with the calculator. But do your thinking in your head. This is a distance because it's a distance between 2 points. So the hypotenuse is always going to be positive. Always. But this going left, negative. Going up, positive. Going down, negative. Going left, negative. Going right, positive. Going up, positive. Going down, negative. So that's the key to doing these. Sorry, I took you over.